So what that formula says is the price of a put on the forward with a strike of 1 over 1 plus KR, and we have a sigma and a T as usual. It's the black price of a call with all the same parameters. We can go back to the call formula, and all we do is change the strike to 1 over 1 plus KR rather than have the original strike of K that we had. We then need the prepaid forward value of the strike. And we need the prepaid forward value of the forward. Now recall that F is by definition the forward value of this zero coupon bond in the black formula. So what are these prepaid forwards? Well, the prepaid forward on a constant dollar is nothing more than a present value. That's equal to P0T times 1 over 1 plus K. 1 over 1 plus KR is a constant. What's the prepaid forward value of that? It's just a present value. And I can use today's zero price to present value it. What's the prepaid forward of F? Well, we saw earlier that the prepaid forward for this forward contract is P of 0, T plus S. So by using the T period zero coupon bond times the strike, and I have a sign error here. Please note this is a minus. It's the prepaid forward on the strike minus the prepaid forward on the contract F. But notice that all of these are now, we can go back to the black formula and get the call price. The prepaid value of the strike is this, using today's zero coupon bond value. And the prepaid value of the forward is the, again, price of today's zero. So with this collection of formulas, we now have the price of a put. And what's the price of a cap? Well, we had a minute ago that the price of a cap was given as the, obviously, this is equivalent to a cap payment. This just produces the caplet payment at time t instead of t plus s. They're equivalent. And it just says it's 1 plus KR times the put price that we just calculated using put-call parity. So after we calculate this put price, the caplet has now a price of 1 plus KR, whatever that caplet rate is, times the put price. And we can now price caplet. So although Black's formula on options on forward zeros may have looked as though this is a contract the market doesn't use, interestingly how a little bit of ingenuity in thinking through the relationship between zeros and interest rates that we're able to convert a call on interest rates to a put on a zero, and by virtue of that connection, use Black's formula by way of put-call parity. We can also price an interest rate cap, which is nothing more than a series of caplets. And this would be common to be done, for instance, in hedging the interest rate risk of a commercial paper borrowing. Let's say that a manufacturer or some company wants to issue 10 million of commercial paper, and it's going to roll that commercial paper every 3 months subject to the then prevailing 3-month commercial paper rate. Well, this would be logical for that company to try to hedge that risk by a series of caplets to fix, for example, the KR value, to fix it so that at every roll of the commercial paper, just like in the single example of a borrowing we looked at earlier, in every roll of the commercial paper, the issuer gets the benefit of the option in the caplet and will pay the better of, the lower of, the caplet rate or the prevailing short rate. So a cap provides a series of caplets which would be a natural hedge for a recurring loan like commercial paper or any floating rate loan, and allows you to, in effect, convert the floating rate payments into, through an option by capping those floating rate payments. So again, you could, this is exactly what we did with the commercial paper example. And so here in more detail, you have a borrower that has a floating rate obligation like commercial paper and knows that at each time in the future, you have T1, T2, T3. Of course, the borrower knows today's commercial paper rate, that's fixed, but then is subject to risk at time T1, T2, T3 as the commercial paper rolls at the prevailing rate. And this issuer knows that it's going to have this prevailing rate, the spot rate at that time for the period. And by issuing, by buying a series of caplets, and a cap is nothing more than a packaged security which packages a series of caplets with the same KR value, this issuer gets the ability to pay as the rate on that commercial paper the smaller of the cap rate and the prevailing rate. Provides an option.